Trigonometry is the mathematics of triangles. And right triangles have very special relationships that we're going to learn about today. The first relationship we're going to look at is the relationship between the lengths of the sides. Side A, B, and C. The Pythagorean theorem states that if you take the length of side A and square it, like this, and the length of side B and square it, and you add A squared plus B squared together, you end up with the square of the length of side C. So the Pythagorean theorem equation is simply A squared plus B squared equals C squared. Let's take a look at an example of that. Here we have a triangle, and in this triangle, our side A has a length of 4 meters, and our side B has a length of 3 meters, but we don't know what the length of side C is. And that's what we're going to use the Pythagorean theorem to solve for. So if 4 squared plus 3 squared equals C squared, then the length of side C is simply the square root of 4 squared plus 3 squared. So C, the length of side C, is equal to the square root of 25, or C is equal to 5 meters. Now here's where you want to put your unit back in. So when we're dealing with right triangles, triangles that have a 90-degree angle in them, not only is there a relationship between the lengths of the sides of the triangle to each other, there's also a relationship between the lengths of the sides and this angle. And we call that angle theta. Now we have names for each of the sides of the triangle that we're going to refer to. The side that's opposite the angle theta we call the opposite. This side over here that's touching the angle, or being touched by this angle, is the adjacent side. And then the long side of our triangle is called the hypotenuse. Now there are 3 functions that correspond with the angle and the lengths of our sides. There's the sine function, the cosine function, and the tangent function. The sine of the angle theta is just equal to the length of the opposite side divided by the length of the hypotenuse. The cosine of the angle theta is just equal to the length of the adjacent side divided by the length of the hypotenuse. And the tangent of the angle theta is equal to the length of the opposite side divided by the length of the adjacent side. An easy way to remember this is with the term SOHCAHTOA. What this tells you is that the sine function is the opposite over the hypotenuse. The cosine function is the adjacent over the hypotenuse, and the tangent function is the opposite over the adjacent. SOHCAHTOA. Now, this is helpful because depending upon which sides you know the lengths of, it'll help you determine which function you need to use. But the problem with SOHCAHTOA is we typically don't want to know what the sine of the angle theta is. We want to know what the angle is. So how do we find that? Now, there's an easy way to fix that. If you know the lengths of the opposite side and the length of the hypotenuse, then you're going to use the sine function. If you know the length of the adjacent side and the length of the hypotenuse, you're going to use the cosine function. And if you know the length of the opposite side and the adjacent side, then you'll use the tangent function. Now, in order to find the angle, theta, using the sine function, you simply punch in sine to the -1 times opposite over hypotenuse. Now this sine to the -1 looks kind of complicated, but it's really just a button on your calculator. So now let's take a look at an example that puts it all together for us. So here we have a triangle, in that if we know the distance the boat is away from the shore, and we can also measure how deep the water is at that point, we can find out the length of this hypotenuse as well as this angle. So to find the length of the hypotenuse, we simply use the Pythagorean theorem, just like I showed you before, where we have 14 meters squared plus 2.5 meters squared equals the length of the hypotenuse squared. So C equals the square root of 14 squared plus 2.5 squared. And punching this into our calculator, we find that C equals 14.22 meters. But what's the angle? Let's look at that next. So now we have a triangle, and we know the lengths of all three sides. Side A is the one that runs in the x direction, which is 14 meters. Side B runs in the y direction, and it's 2.25 meters. And side C, which is the hypotenuse of our triangle, which we discovered was 14.22 meters. Now, the angle that we're looking for, angle theta, can be found using the sine, the cosine, or the tangent functions. Now, for this triangle, we really want to use the tangent function, because the two sides that were given to us are the lengths of the opposite side and the adjacent side. We figured out what the length of the hypotenuse was, but we rounded this number off. So it's really better to use numbers that haven't been rounded. So according to our equation, the angle theta is equal to the inverse tangent of 2.25, which is the length of our opposite side, divided by 14, which is the length of our adjacent side. Now at this point you want to make sure that your calculator is in degrees and not radians, and when you press enter, you find that our angle theta equals 9.13 degrees. And that's this angle right here.